So here we have a function. This is example number 3, where we've got these very large powers. Okay, so we don't want to go ahead and multiply this guy out. We could, but we don't want to. We need to find the rate of change of y with respect to x. So what we're going to do is we're going to use the rules that we've done so far. And what I have is a combination here of the product rule, okay, the power rule, and the chain rule all together. So what I'm going to do is I'm going to write this guy out like this. I'm going to say, okay, dy dx is equal to d dx, the derivative of the first guy. I'm going to write it like this. I want to make sure it's nice and neat. Times the second guy plus the derivative of the second guy times the first guy. Okay, so there's our product rule that just came in. Now, what I'm going to do here is I'm going to make a substitution for these two guys right here. I'm going to call this guy U, and I'll call this guy over here V. So U, and actually let me do it so that they're in different colors. So U is going to be equal to x squared plus 1, whereas V is going to be equal to x to the 4th plus 3x plus 1. Now what I'm going to do is I'm going to replace those in here. So I'm going to say, okay, this guy over here on the right is d dx of u to the 27th times v here. I'm going to leave that in there, okay, because at the end, actually I wouldn't have to, but at the end I'm going to want everything in terms of x, so I'll just leave that. Plus d dx of v to the 8th times x squared plus 1 to the 27th power. Now here the situation is I'm trying to take the derivative with respect to x of u. Well, I can't do that, okay, because these variables have to match, so I need to make a substitution here. And so what I'm going to do is I'm going to say that this guy right here, I'll do it in blue, this guy right here is going to be equal to the following. It's going to be equal to du dx times d du of u to the 27th times x to the 4th plus 3x plus 1 to the 8th. So again, what I want you to notice is that if I crossed out these du's, I'd be left with d over dx. I'd be left with this guy over this guy. So it's an easy way to remember where you came from. It's not correct to cross them out, but it's easy to remember where you came from. Now the other side over here is I have d dx, but I have the variable v here, so I need to make a substitution as well. So I'm going to change d dx into dv dx times d dv of v to the 8th. Like that. So this guy over here, du dx, well here's u. So as a side note, since u is equal to x squared plus 1, then du with respect to x is equal to just 2x. So this guy right here is 2x. Now, I'm going to erase this so we've got room. Now, this guy, d du of u to the 27th, that is equal to 27 times u to the 26th. And then, of course, we still have this guy hanging out here at the end, so we'll put that guy in. Okay. Now let's work on this guy over here, and I'll work on simplifying this in a minute. So dv dx is the derivative of this guy with respect to x. So dv dx is equal to 4x to the third plus, oops, not plus 3x, just plus 3. Okay. And now we'll multiply that by d dv of v to the 8th, which we know is 8v to the 7th. And of course, we got this guy here at the end trailing along. Okay, now this 2 times 27 is 54. The x is still there. The u value, u is equal to x squared plus 1. So this is going to be x squared plus 1 to the 26th. And this will be x to the 4th plus 3x plus 1 to the 8th. Okay, that's that guy right there. Okay, now plus, we're going to have an 8 out front. Okay, I'm going to put this guy back in because it really doesn't matter the order. And then I've got v to the 7th. Well, v is this guy, so x to the 4th plus 3x plus 1 to the 7th, and then x squared plus 1 to the 27th. And that is going to be your final solution. And so we can go ahead and just leave it. We can leave it like that. If we can factor some stuff out if you want to. We could say, we could pull out an x squared plus 1 to the 26th. So like this, x squared plus 1 to the 26th. So I'm getting out the GCF, and then we can get x to the 4th plus 3x plus 1 to the 7th out. And then what's left over is 54x times x to the 4th plus 3x plus 1. And then back here, we've got an 8, a 4x to the 3rd plus 3, and an x squared plus 1, let's see here, to the 1st power. Okay, we can multiply this stuff together, and we can sit here and reduce until we're blue in the face. Okay, but this right here, this line is really what we're looking for.